Next question here is question 2. I just found it there. Yeah, I just want to show you so that you know that we are not joking around there. I'm sorry. Now this is the question. The next question here. So now they said if alpha and beta, I already typed it there, so let me just go there directly. See, given that alpha and beta are the roots of the quadratic equation 3x squared plus this minus equal to 0. Now find the quadratic equation whose roots are alpha squared over beta and beta squared over alpha. What do you need to do? First, find the sum and product of the roots they gave us. We already know that our root is alpha and beta. So what do we need to do? Just go and take the sum. And if you compare, I don't know if you guys remember how to do these things. Maybe I should make a short video on how to do it so that you guys don't have to. But actually, the standard quadratic equation is ax squared plus bs plus c equals 0. Now, given that alpha and beta have the root, if you reverse the order, that is getting a quadratic equation from its root itself, you get your own new equation to be of the format x squared minus into bracket alpha plus beta with s plus alpha beta equals 0. This is what you get. Are you get what I'm saying now? Now, how do we get our alpha plus beta to be minus b over a? The next thing we do was to say, okay, since the coefficient of x here is x squared here is 1, then make the coefficient of x squared here to be 1. In this other one, make the coefficient of x squared here 1. What do we do? To do that, we just divide both sides by the coefficient of x squared. Divide both sides by the coefficient of x squared. So this divide this. So our x squared now matches x squared. So now, x squared match, comparing both this one, comparing equation 1 and equation 2 now, x squared matches x squared, nothing new. All together. Now, minus into bracket alpha plus beta, we match what? B over a. Then take the minus to the other side. That's how we get this one. And alpha beta will match what? C over a. Comparing coefficient. So our sum is what? Minus b over a. And our product is what? And our product is c over a. Sum being alpha plus beta, product being alpha times beta, and then we get that. Now, how do you get your a, b over a, c over a, and all of that? Just write the standard quadratic equation, compare it to the equation you are given. From there, the coefficient of s squared will be your a, the coefficient of s will be your b, and the constant will be your c. The coefficient of x, if any of those numbers, listen, if any of those numbers is having a negative sign, the negative must follow it into what you're going to write. So the coefficient of x of b is actually minus 2, not ordinary 2. So bringing it back to the expression, alpha plus beta is going to be what? Minus into bracket, there's a minus here and there's another minus here. So that's why we have minus all over the coefficient of a is what? 3. So that's why we get 2 over 3. And the product is c over a. C is 1, a is 3. That's why we get what? 1 over 3. Now, the next thing you do, just like what we did when they gave us alpha and beta to be the root of our equation, what did you do? We took the sum and the product. Listen attentively. In this aspect of mathematics, symmetric property, if there is a given root and they want you to find another root, take the sum of that root and the product of that root, and that one, the way they do this is, so the way we give question in this aspect is that alpha and beta are always the root, like normally. Only if you want to change it to alpha beta, but we use alpha and beta. We want to give you alpha and beta to be root. Take the sum, which is minus b over a. Take the product to be c over a. For you to get the real value, what is sum and product of the root they gave you with that given equation. Now with that, we've been able to get the root. Now what do we go? Now the equation you want to find, the new root, the same thing you did to the old root, you're going to do to the new root. Same thing you did to the old root, you are going to do to the new root. The old root they gave us, what did we do? We took the sum and the product. This new root too, we are going to take the what? The sum and the product. Simple. So that's what we do. The sum of this, how do we do that? That will be alpha square over b plus beta square over, alpha square over beta plus beta square over alpha. Then of course, fraction. You know what you do around fraction, right? Take your LCM. That's alpha beta. No, beta in alpha beta, you're left with alpha times alpha squared. That will be alpha, there's raised to power 1 and raised to power 2, 1 plus 1, alpha raised to power 3. And this one, alpha in alpha beta, you're left with beta raised to power 1 times beta raised to power 2. That will be beta raised to power what? 3. So sorry, that will be plus. There's a plus in between them, no minus. So that's how we got this beautiful looking expression there. Now the next thing we want to do is that whatever you get, note, please note, whatever you get, you must always write it back in some product form. Alpha cube plus beta cube, there's nothing for it in symmetric property if you don't convert it to what it should be in some product form. So that's what we did here. That's a little bit of symmetric property around there. And if there's any of these things I use you don't understand, feel free to talk to me. Comment in the video. Symmetric property, can you further explain? Of course, we do that. I can take a video, a series on it, then explain how we get each of these things. That's if you don't understand actually. So alpha cube or beta cube, from symmetric property we get to know that it is alpha plus beta, then open bracket alpha square plus beta square minus alpha beta. Now alpha square plus beta square again is actually alpha plus beta all squared minus 2 alpha beta. Are we together here? Are we getting what I'm saying at all? Please get it straight. So what do we now have now? Now we now have substituting this place for this one here, this one for this one here. So we now have what? Let me write it there. We have into bracket alpha plus beta, then a big bracket. Now this one will now be what? Alpha plus beta all, don't mind my handwriting, all squared. Then there's a minus alpha beta, there's another minus 2 alpha beta, that will be minus 3 alpha beta. Close it up. Are you here? So that is it. Now if you want to do it the better way, we want to do it the best way we figured we can do it, is that what we do there is just as easy as it looks, which is just now. Oh, what we did there was actually what I did actually, they simplified this first. Easy mathematics, we simplified this first. I simplified this first. Actually, when I was trying to compute the answer, I compute it first, because for now we don't have a screen and to write it directly to be solving one by one. So I compute the answer, then I explain it. So now this was what I did first. I simplified the answer, that is, since we already know what alpha plus beta is and we already know what alpha beta is, our alpha plus beta, don't forget what we got for that. Our alpha plus beta we already get what? 2 over 3, and our alpha beta will get 1 over 3. So we substituted that into this place, and substituting it into that place, what do we get? That will be 2 over 3 all raised by 2, then minus 2 times 1 over 3. 2 raised by 2 is 4 over 9, and then minus 2 over 3, simplifying it to get minus 2 over 9. So now what will our alpha cube plus beta cube be? That's just where we are going now. All together here, that will be the whole of this alpha plus beta, which is 2 over 3, and the whole of this we've gotten the value already, which is what? Minus 2 over 9, and we know that our alpha beta is what? 1 over 3. So simplifying the fraction, deal with the inside first before the outside. You know the rule of fraction. You don't play around fraction. Go by the rules so that you don't get something wrong at all. Okay, I will still do that because I said I promised to make this video as simple itself can be. So let me go around it now. That will be minus 2. Do the minus 2 over 9 plus 1 over 3 first. So the LCM here is going to be 9. So 9 1 times this minus 2, 3 9, and then we get plus 3. So this is where we get what? Our 1 over 9 from times the one outside, 2 over 3. So that will be 2 over 27. That is our alpha. Now, but there's something more to it. All together here, 2 over 27 is not all. Why? Somebody is saying, why is that not all? Don't forget, 2 over 27 is just for this side, alpha cube plus beta cube. What of over? There's divided by there's divided by alpha beta. So that was what we eventually did here. So that will be 2 over 27 divided by 1 over 3, and that will be 2 over 7 times 3 over 1. And from there, that will be 2 over 27 times 3 over 1. 3 here 1, 3 here 9. So the sum of the new root we are looking for is actually, or we're solving for, or we want to get, is actually 2 over 9. Now the next thing we do is what? Let's go straight ASAP to what? The product. I said once they give you a new root, find a sum, get the product. The product will be alpha over beta. That's what we have here. Alpha square over beta times beta square over alpha. And you know how that's going to look like. That will be alpha. I said alpha square over beta times beta square over alpha. Alpha here 1, Alpha cancels this. Alpha, beta. So you are left with what? Alpha, 1 alpha times 1 beta. So that's alpha beta, which is actually the product. So alpha beta is what? We already said the product of the root is what? 1 over 3. So the product of these are new root 3 is 1 over 3. Beautiful. Maths can actually be always be beautiful though. Now, how do I now get, for you to get any equation at all, the standard rule to getting any quadratic equation at all, not cubic, not quartic, and all those higher degrees, but for any quadratic equation, once you know the sum of their roots and you know the product of their roots, this is the standard format to get the equation back. That's s squared minus sum of the root, and that was what we did to get alpha. That was when I was proving alpha plus beta and all of that, minus sum of the roots with s plus product of the root. Now our sum of roots, sum of the new root we got was what? 2 over 9, and the product of our new root is what? 1 over 3. So we substituted that, and then we get x squared. With that we get x squared minus 2 over 9x plus 1 over 3 equals 0. Now what do? Multiply both sides by the LCM, that is 9. Multiply this one by 9, multiply this one by 9, multiply this one by 9. 9 cancels 9 here. This will be 9s squared minus 2s, and 3 here 1, 3 here 3. That's plus 3. So the new equation we are looking for is this. 9x squared minus 2x plus 3